Hi guys, welcome to the Creating Smart Maps with Python and Leaflet course. In this course, we will be building a full-stack GIS application in Python using open source software. So the purpose of this application is to combine geospatial analytics and software development to create smart GeoDjango applications. We will be working with residential water consumption data, and we will be applying data processing techniques to extract, transform, and load the data into our spatial database. Once we have cleaned and processed the data, we will use it as our data source for building our GeoDjango web application. We will be powering our application with a PostgreSQL and PostGIS database. In the front end, we'll be using Bootstrap, JavaScript, Leaflet, and Ajax. In the back end, we will be using Python and Django, combined with the use of scientific libraries like pandas for our data processing. The operating system that we are coding in is Ubuntu Linux LTS. We will be displaying a smart map that will display the average water consumed by each suburb in the Cape Town region in kiloliters for that month. We will be displaying this information in a bubble plot, also called circle markers. So the size of the circle determines the amount of water that's consumed in kiloliters by each suburb. So the bigger the circle is, the more water the suburb has consumed, and the smaller the circle is, the less water the suburb has consumed. We will also be visualizing the top 10 suburbs that have consumed the most amount of water, and we will display that information in a horizontal bar chart. We will also add a map legend, which is custom made with CSS, to display the classes of consumptions that we see on our map. So the data is fed into the map by a web service that we will create. As you can see, we can get the data by calling the endpoints. We can also change our base maps using the layers control to display the data from a different viewpoint. For example, if we want to see how the suburbs look like, we can use the Esri World Aerial Map. And if we just want to focus on the data, we can switch over to the dark map and we can analyze the data in this view as well. So that's the application that we will be building in this course. I hope you guys will enjoy it and learn a lot from it. And I'm looking forward to seeing you in the course. Thank you. Hi guys, welcome back. In this lesson, we will be installing and configuring PostgreSQL and PostGIS. So let's open up our terminal. Okay, and now let's switch over to the root user. Okay, and now the first thing that we need to do is we need to add a repository for PostgreSQL. And then we add the key. And now we can update our environment. So now we are ready to install PostgreSQL. So let's run the following command: sudo apt-get install PostgreSQL. Okay, once PostgreSQL has been installed, we can now install PostGIS by running the following command: sudo apt-get install PostGIS, PostgreSQL 15, PostGIS 3. Okay, so now we have successfully installed PostgreSQL and PostGIS. So that's it for this lesson. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be installing GDAL, which is a required library for developing GIS applications and handling geospatial data. So let's first update our system by running the following command: sudo apt-get update. Okay, and now let's install the GDAL libraries. Okay, so once we have installed GDAL, we are now ready to create the geospatial database for our application. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be creating our spatial database. This will store the tables and data that will be used by our application. So the first thing that we need to do is enter the command line interface of PostgreSQL in full admin mode. So this is the default user that's created for you when you install PostgreSQL. Okay, so now we are going to create our database by running the following command. Create db cpt water. So the name of our database will be cpt water. So now the next thing that we need to do is create a new user for our application to access the database. So let's do that by running the following command. Create user -s waterwatch -p. Now we need to add the password. So the password that we will use for this user is just Postgres for simplicity's sake. Okay, so now let's enter into our database from the PostgreSQL shell. So the first thing that we need to do is grant all privileges on our database to our user, which we have called waterwatch. Okay, and the next thing that we need to do is add GIS extensions to convert our database into a geospatial database. So the first extension that we will add is PostGIS. And then the next extension that we will add is PostGIS topology. Okay, once we have done that, we can quit the PostgreSQL terminal by running \q. Okay, so now we have created the spatial database and user for our application. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be creating our project folder as well as creating a virtual environment for our application. So the first thing that we need to do is create a new folder for our project. So let's open up our desktop directory in our terminal. And now let's create our project folder. We will call it Ebesis Tutorials. Okay, so inside our project folder, let's create our application folder. We will call it Waterwatch. Okay, and now we are ready to create our virtual environment. We will be using a tool called virtualenv. Virtualenv will allow us to create a Python virtual environment for installing our third-party libraries, which we will package with our application instead of installing them directly in the Ubuntu system. But first we need a tool called python3pip, which is used to install Python third-party libraries. So let's install python3pip. And now let's use pip to install virtualenv. So let's run the following command. pip3 install virtualenv. Okay, so virtualenv has been installed successfully. So now the next thing that we need to do is create our virtual environment by running the following command. virtual env venv. So venv is the name of our virtual environment. It can be any name. In this lesson, we will call it venv. Okay, so our virtual environment has been created. So now let us test and see if our virtual environment works. So to activate our virtual environment, we will run the following command: source venv bin activate. Okay, so you will see the prefix is venv. So this means that our virtual environment is active. So any Python third-party libraries we install now will be installed only in our virtual environment, which is separate from our system, so that we don't have any conflicting third-party libraries. So now to deactivate it, we can just type deactivate. Okay, so that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be installing and configuring GeoDjango. So the first thing that we need to do is we need to activate our virtual environment. Once our virtual environment has been activated, we need to make sure we are in our project folder. Okay, so now we are ready to install Django. So let's run the following command to install the Django framework. Pip install Django. Okay, so now the next thing that we need to install is a library called psychopg2. So this library will allow us to connect to our PostgreSQL database from our Django application, and will also allow us to read from and write to our PostgreSQL database. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be installing our IDE. So the IDE that we will be using to write the code for our application is Visual Studio Code. So let's download the IDE and install it. Let's open up our web browser. Then we search for Visual Studio Code download. And then we select this link, code.visualstudio.com. Okay, and then we select the Debian file for Linux. And wait for it to finish downloading. Okay, so now let us install Visual Studio Code. Okay, and now let's verify that Visual Studio Code has been installed. Okay, so as you can see, Visual Studio Code has been installed successfully. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will start to create our application. So we are just going to create a Django based application. So we make sure that we are in our project path. So let's run the following command to create our Django project. The name of the project will be WaterWatch in small caps, and then we add a space and a point. Okay, so now our Django base application should be created. Okay, so now the next thing that we need to do is create another folder called WaterWatch app. So Django requires that we have the project folder as well as the app folder. So the app will contain all our model view controller files. So that's basically all the server-side code that we will create for our application. Okay, so now let's create our app. So first make sure that we are in our project root directory, so we can use the manage.py file to create the app folder. So let's run the following command: python manage.py start app waterwatch app. Okay, so now our app folder should be created. Let's verify that. Okay, so as you can see, we have our WaterWatch app folder created. So now let's have a look at the files inside. So now we have created a complete Django-based project. So now we will start to write the application code for our project. So that will be it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be testing our Django installation. We will do this by running the application. So the first thing that we need to do is change the permission of the project folder so that we can open it in Visual Studio Code. Okay, so let's deactivate our virtual environment and go back to our desktop directory. Okay, and now let us run the following command to change the permissions of the project folder. Okay, and now we have enabled full permissions on this folder. This is not a very secure approach, but because our focus is on learning GeoDjango, we won't worry about the details of the file permissions for this course. Okay, and now the next thing that we need to do is we need to open the project source code inside our IDE. So let's open up Visual Studio Code. Okay, and then select the Explorer button, and then select Open Folder, and then we locate our project source code. So here's our project folder, and then click on Open Folder. Okay, so as you can see, our project has been opened in our IDE. So the next thing that we need to do is we need to install the Python extension. So we click on Extensions, and in the search type in Python. Okay, and then click on this extension. It says Python by Microsoft, and then click on Install. So we're just waiting for the extension to complete installing. Okay, so the extension has been installed. So let's close this, and we can close this window as well. And let's go back to Explorer. Okay, so the next thing that we need to do is we need to open up our terminal from within Visual Studio. So we click on View and then select Terminal. Okay, so it should automatically activate our virtual environment. If it doesn't, then we can just manually activate our virtual environment. Okay, so now the next thing that we are going to do is we are going to run our application server. So to do that, we will use the manage.py file. Okay, so here's the manage.py file in the project directory. So now let's run our server. Python manage.py run server. Okay, so as you can see, our server has started at port 8000 using the localhost IP. So usually I just hover over this IP and then click on follow link, or you can just copy and paste it in the web browser. So the quickest way is just to click on follow link. Okay, so now we should be able to see the Django page that tells us that the installation worked successfully. So now we know that our Django application is running successfully in this URL. Okay, so that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will update our settings.py code. We will also establish a connection to our spatial database that we have created previously in the Ubuntu shell. So we can close this window and then we can terminate the server by pressing Ctrl C. Okay, so first we need to install a couple of third-party Python libraries that will allow us to manipulate geospatial data from within our application. So our virtual environment has been activated. So now we can install the libraries. So the first library that we need to install is Django leaflet. Okay, so that was successfully installed. And the next library that we need to install is Django GeoJSON. So this will allow us to read and manipulate geospatial data in JSON format. Okay, and then the last library that we need to install for now is just GeoJSON. Okay, so now we have installed the geo libraries that we need. So now the next thing that we need to do is we need to start modifying the source code. So we will start by modifying our settings.py code. So let's open the settings.py file. Okay, so the first thing that we are going to do is we are going to add the django.contrib.gis app inside the installed apps. So we will create another element called django.contrib.gis. Okay, and then we need to add our own app, which is called waterwatch app. Okay, so now the next thing that we are going to do is we are going to modify the database connection string, which is over here. So this will define the connection string to allow us to connect to our spatial database. So first of all, the engine that we are using is PostGIS. So we're not using SQLite. Okay, this is the engine that we will use. And then the name is the name of the database that we will be using. And we said that the name of the database would be CPT water. Okay, so we also need the username that we will need to connect to our database. And the user which we have created in the PostgreSQL shell was waterwatch. And then we need to add the password for the user. And we said that the password was simply Postgres. So that's the same password that we use for every application. Okay, and then lastly, we need to specify the host. So the host is which IP the database is running on. And in our case, it's running on localhost. Okay, so now we've updated our settings.py code. And now we can run the migrate statement so that the database connection will be created. Okay, so let's do that. So first we save the source code with Ctrl S. Now in our command line, we will run python manage.py migrate. Okay, so the connection to PostgreSQL has been established. So now we have established a connection to our PostgreSQL database from within Django. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be creating the Django admin user. So Django has an administrative portal that allows us to connect to our database and then test and see if we can retrieve the data that has been stored in our database. So it's a good tool to use to test and see if you can make a connection to your database. So firstly, we need to create the user so that we can log into the admin console. So to do that, we are going to run the following command: python manage.py create super user. Okay, and the username will be the same username as the username for our database. So we want to keep the same username and password. So it's waterwatch, and then just press enter to skip the email, and then enter the password. The password would just be Postgres. And then type it in again. Okay, so we can see the super user has been created successfully. So now let's test and see if we can log into the Django administration portal. So let's run the server. Okay, now let's open up the URL link where our server is running at. Okay, so now over here we are going to add a /admin for the admin portal. So now let's type in our username that we have created, and then the password we said was Postgres. Okay, so let's go to users to verify that our user has been created. So as you can see, we have created our user successfully, which is waterwatch. Okay, so that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will create the model class of our application. So the model will be the table which will store the data that we will be working with, and that is created in the models.py file. So if you haven't already, you can close the web browser and terminate the server. Okay, and then the next thing that we need to do is click on models.py. Okay, so now we can add the source code. We'll start by commenting out the first import statement that we see here, because we are not using a standard Django model. We will instead be using a GIS model. Okay, so we can do that. So we added this app in our settings.py file, which is django-contrib.gis. And now we are using its model. So if we go back, you can see that we have added it as an app over here. So now we will use it in our application. Okay, so now the next thing that we need to do is we need to create a model, and that is created over here. We can see create your models. So basically a model is just a class. I'll copy in the class that I've created for the application, and then we will go through the code. So it's pretty straightforward. So to create a model, we create it as a class, and then we give the class a name. We will call it water consumption, and then we give it a type, which is a model. So we are saying that this class is a geospatial model. And then we add the fields. So we'll have an ID, and then we specify the data type for that field. So this is an integer type field. So you would say ID equals models.integer field. And then we specify that this is a primary key. And then we have a suburb, and that is of type char field. And then we give it a length of 100 characters, and so on. Okay, and then we get here. So this will be the field that will store all the GPS coordinates So our latitude and longitude values will be stored in the geometry field. So it's of type point field. So this type of field is only available in a GIS model. Okay, so basically this is creating the schema for our table in PostgreSQL. So these will be all our fields in the table, and this will be the data types. This will be the name of the table. We'll call the table water consumption. Okay, and over here is where we add some metadata. So basically we're saying that each record in our table will be grouped by a suburb. So the name of the suburb will be unique. So each record will be identified by the suburb. And then if you click on the suburb, you will see all the information for that specific suburb. And this is only necessary when using the Django admin portal. Otherwise, it doesn't really matter in PostgreSQL. Okay, and then we're just giving an alias to our model. This is how we want our model to appear in the Django admin portal. So we're just giving that the same name as the table name. Okay, and then for instance, if we want to create another table, we just create another class. So you would just create another class below, and we'll give it another name like dams model, and then we'll just add the fields, etc. So that will be the second table. And then the name of the table would be dams, and what you create beneath would be the fields. So that's basically how you would create a model in Django. And this model will be converted into a table in PostgreSQL. Okay, so we can save the code. Okay, and now the next thing that we need to do is run our migrations to make sure that our changes have been saved and that this table gets created in PostgreSQL. Okay, so we run python manage.py make migrations. Okay, so you can see that the model will be created in PostgreSQL. So now we need to run migrate, python manage.py migrate, and this will actually save the settings and create the table in PostgreSQL. Okay, so the table has been successfully created for us in PostgreSQL. So in the next upcoming videos, we will be testing this in the Django admin portal. So that's where we will test and see if our data has been stored successfully and if our PostGIS and PostgreSQL have been integrated successfully, and also that our application is able to read and write from the Spatial database. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be downloading the dataset that we will be working with in our application. So let's open up our web browser. Okay, so we can search for Ebus's GitHub. Okay, and then let's just click on Ebus's GitHub. Okay, and then we can select the WaterWatch repo. So the file that we want is this one, which is called waterwatch_clean2.xlsx. So we can click on that and then just click on download. Okay, so let's locate the file. So now we copy the file into our project and root directory. So we locate our project. So the same place where the manage.py file is, we paste it there. Okay, so now that we have done that, we can see that our file is an Excel file. So we have to download the third-party libraries that we need in order to read Excel files, as well as the data manipulation library that we will use to transform the dataset. So we can close this window. Okay, so we just verify that the file is there. Okay, so now let's install the third-party libraries that we will need to read the Excel file. So the first library that we will install is XLRD. and then we run pip install openpyxl. So this is also an Excel reading library. Okay, so that's downloaded successfully. So now the next library that we need to install is the one that we will use to manipulate our dataset from our application, which is pandas. Okay, so pandas has been installed successfully. So now we have our data manipulation libraries installed. So now let me just give a run through of the data set that we will be working with and how it applies to our application. So our application analyzes the amount of water that gets consumed by each suburb for the given month. So the value will be in kiloliters, the average monthly kiloliter of water consumed by each suburb. So we want to identify the suburbs that are consuming the most amount of water. And then we want to target those suburbs and then maybe send out an alert email notifying them that they are consuming too much water and that they need to cut down. Or we can alert the municipality and they can control the amount of water that gets distributed to those suburbs. So basically that is the reason why we are working with this dataset and how it applies to our application. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be adding the code for the admin.py file. So let's open the admin.py file. Okay, so the code that we will add will read from our dataset file that we have downloaded over here. And then we will extract the data into a pandas data frame. And then from there, we will transform the data so that we can store it in our spatial table. But before we do that, we need to use an object from the leaflet class. We will add the leaflet app in our settings.py file. So let's open that. And then in the list of installed apps above the WaterWatch app, we will add an app for leaflet. And then add a comma. Okay, and then save the file. Now open up the admin.py file again. So now let's add the code for our admin.py file. So firstly, we will add a couple of import statements. Okay, so we want to add a point object. So this will store our latitude and longitude values. And then we will also be importing the datetime object in order to get the current date that we will use to insert a record into our table so that we can see the date and time in which the record was inserted. And then we will also be using the leaflet GeoAdmin class. So in the admin.py file, you have to register your model as well as the admin class. And instead of importing a standard Django admin class, we will be using a leaflet GeoAdmin class. And we have gotten that from the leaflet app that we have just added over here. Okay, and then we will import our model. So we need the model to be registered to the admin class. And then we will use pandas to do our transformations as well as read from the data file. So let's first create a GeoAdmin class. Okay, so basically in order to register this admin class, we need to specify the name of the model over here, as well as append the word admin. So this is what Django requires. And then we specify the type of admin class that we want to use. We want to use the leaflet GeoAdmin class. So that's all we have to do. And now you need to register the class. So it's just admin.site.register. You pass in the model as well as the admin class for that model. Okay, so that's what we have to do before we can use the model. Okay, and now the next thing that we need to do is we need to read in the contents of the data file into a pandas data frame. Okay, so we just create a variable to store our data frame. We call it dfxlreader. And then we use pandas.readXL in order to read Excel files. If we wanted to read a standard text file, we would use read_csv. And then we specify the location of the file. Okay, so now we need to test and see if we are able to read from the file. So we're just going to print the first 5 records of the data frame. So we use the head function to print the first 5 records of the data frame. So let's save the file and then run it to see if we are able to read from the file. So it's python manage.py run server. Okay, so as you can see, we have successfully read from our file, and here we can see the contents of the file. We have the suburb field, which is the name of each suburb. We have the average kiloliter consumption value in this field, and then we have the latitude and the longitude value for each suburb. Okay, so now we can terminate the server with Ctrl+C. Okay, we can comment out this line because now we know that the data is stored inside of our data frame. Now the next thing that we need to do is we need to loop through each record in the data frame and then write the record to our table. So let's add the code for that. So if we want to loop through a pandas data frame, we need to create a for loop. So we specify an index and a row. So all of the contents of each row will be stored in this row variable, and then the name of the data frame .iterows. So that's how you loop through a pandas data frame. Okay, so now the next thing that we need to do is we need to store each value of the record into a variable, and then we use that variable to write the record into our table. So we just create a variable with the same name as the field name. So for instance, the suburb we extract from the row, and then we search for the suburb field and we extract the value and so on. And then here we have the longitude and latitude values. So they are 2 separate fields. We will combine them into one object, which is the point object. So that's why we have imported the point object. Okay, so now we are ready to save this record to our table. So we are going to use the model that we have imported. So basically, if we want to insert a record, we do the following. We take the field name inside of our model and we assign it to the value that we have extracted and stored into this variable. And then to get the suburb, we add the value which is stored in the suburb variable, and so on. So for each field, we extract the specific value, and then we assign it to a field name from our model. So we will be doing that for every field. So I'll just copy the code for that. Okay, so once we have done that for every field, we save that record into our table. So over here we have the geometry field, and we use the point object in order to group the longitude and the latitude values. So that is how we will be storing the location information for every suburb. And then we add save to save the records, and this will loop through every record in our data frame and then store the record into our water consumption table. So let's save the file, then run the server and test and see if our data has been inserted into our table. Okay, so we have no errors. Now we can open up our application in the web browser. Click on follow link. Okay, so now we will verify that the data has been inserted into our table using the Django admin portal. So we add a /admin. Okay, so firstly we can see that our table was created for us, and now let's click on that. Now we can see the value of every suburb. So our table now contains data that was inserted by our code. And if we open up a suburb, we can see the information that is stored about the suburb. So we have the name, we have the ID value, which is just the index, and then we have the average monthly kiloliters consumed, as well as the geometry object, which contains the latitude and longitude values. So it stored that as a point. So we can see when we look at the name of the suburb, it matches the suburb name on the map. And you can see that the point is placed accurately inside the suburb. So basically, if you see the leaflet map and the point is accurately plotted, it means that the spatial database has been successfully configured and integrated into our application. So now we can start to move on to creating the visual aspect of our application. We can use the data that we have stored in our spatial database and display it on the map. So that's it for this video. I'll see you guys in the next one. Thank you.